Today we shall discuss about two hinge arch. So in the two hinge arch, we have only two end. We have support at two end, and we don't have any hinge portion in the crown. So this is two hinge arch, and the support condition may be hinged or fixed, whatever it is. So now we have one vertical reaction at this point, another vertical reaction at this point, one horizontal thrust, this is another horizontal thrust. So at point A and B, we have vertical reaction at A and vertical reaction at B, and a horizontal reaction at A and B. So we have four reactions. Okay, 1, 2, 3, 4. We have four reactions, and we have three equation of equilibrium. Summation of vertical equals to 0, summation of horizontal equals to 0, and summation of moment equals to 0. So we have three equation and equation of equilibrium, and we have four reaction. Okay, so we have greater reaction than the equation of equilibrium. That's why it is indeterminate structure. And degree of indeterminacy, degree of indeterminacy in degree of indeterminacy will be 4 minus 3, 1. Okay, so let us try to solve one problem. Let us consider one two hinge arch subjected to a point load W, okay, at the midpoint at crown. So at two end we have vertical reaction VA and VB, and we have two horizontal thrusts that we have to calculate also. Now this is a circular arch, okay, semicircular arch. So we have the radius, say the radius is R. And one thing you have to memorize, that is to calculate the horizontal thrust for two hinge arch, we have a formula, that is H is the horizontal thrust, H equals integration m y ds divided by integration y square ds, and this m is actually bending moment. Okay, so this is the formula to calculate the horizontal thrust. And one thing you have to keep in mind, that to calculate the moment, we have to consider a particular section at say x distance from point A, and height will be y. So relation between x and y is y equals 4h by L square into x into L minus x. This is the formula. Now to calculate the vertical reaction, it is very easy. First of all, summation of vertical force equals to 0. So VA minus W plus VB equals to 0. This is the equation 1. And another equation is summation of moment equals to 0. So VA or VB taking moment about point B. So VA into 2R clockwise moment. So let us consider the clockwise moment is positive and the dialog give you anti-clockwise moment about point B. So it will be negative. So minus W into R equals to 0. So VA equals W R divided by 2R equals W by 2. And from the first equation, we can get VB equals W minus W by 2, that is also W by 2. So VA will be W by 2 and VB will be W by 2. Now the horizontal thrust H equals integration m y ds divided by integration y square ds. This is the section. Let us consider this is the section, okay, and this distance is ds and the angle is d theta, and the radius is r. The relation between ds, r and d theta is ds equals r d theta, okay. So at this section the moment will be moment due to the vertical force only, also of course moment due to the vertical force VA will be force into perpendicular distance. So this is the distance and force will be W by 2. So this distance we can write r minus r cos theta. This distance will be r minus r cos theta. The total distances are from this point to this point. Distance is r, and from this point to this point, this is r cos theta. So this distance is r minus r cos theta. So moment will be force into distance. Force is w by 2 and distance is r minus r cos theta. So we can write integration w by 2 r minus r cos theta. This is the moment, and the value of y is, this is the y. Okay, so this value is actually y is r sin theta. So you can write the y value, that is r sin theta. And instead of ds, we can write r d theta. R d theta. And we are going to consider the half portion, okay, a to c. So limit will be 0 to pi by 2 multiplied by 2. So we are considering a to c portion only, that's why 0 to pi by 2. And again we have to consider the total arch a to b, that's why we are multiplying 2. Okay, and this portion is y square ds, and y square means r square sin square theta, and ds means r d theta, and the limit will be 0 to pi by 2. So h equals w by 2 0 to pi by 2 limit 1 minus cos theta sin theta d theta, and this is 0 to pi by 2 sin square theta d theta. If we are considering 1 minus cos theta is equal to u, so we can write sin theta d theta equals du. Okay, so integration 1 minus cos theta sin theta d theta will be u du. that is u square by 2. So the answer of this portion will be 1 minus cos theta whole square by 2. And sin square theta d theta 0 to pi by 2 will be pi by 4. So one minus cos theta whole square by 2 and put the limit 0 to pi by 2 here divided by pi by 4, and we will get w by 2, and this value is half divided by pi by 4. So the answer is w by pi. This is the answer. So the horizontal thrust will be w by pi. Okay. Let us try to solve another example, that is a semicircular two hinge arch subjected to UDL W. না আসেননি, এখানে ম্যাম আজকে আসেন, ম্যাম আসেননি আজকে। So you have to calculate vertical reaction and horizontal thrust for this two hinge arch which is subjected to a UDL W per unit run. So this is the center and this is radius r. So let us try to calculate the vertical reaction. Summation of V equals to 0. So VA plus VB minus W into 2R equals to 0. Equation 1. Another equation is summation of moment equals to 0. So taking moment about point A, so VB into 2R minus W into 2R into R equals to 0. So VB will be W into R. So from the equation 1 we can get VA is also 2 W into R. Okay. So VA will be WR and VB will be WR. Now at any section you have to calculate the moment. The moment will be force VA, that is WR, into this distance, that is R minus R cos theta, or R into 1 minus cos theta. And moment due to UDL, that is W into R into 1 minus cos theta whole square by 2. So the moment will be the simplification, if you simplify this formula, you will get W R square by 2 sin square theta. Okay. Now horizontal thrust H equals, we know the formula, integration my ds by integration y square ds. So integration W r square by 2 sin square theta into y, and y means r sin theta. This is the y. Okay, this is the y, and this is theta, and this is r. So y will be r sin theta. And ds will be r d theta divided by integration y square ds, that means r square sin square theta r d theta. Now put the limitation, that is 0 to pi by 2 into 2 and this is 0 to pi by 2 into 2. So the answer will be 4 by 3 W R by pi. So this is the horizontal thrust. 4 by 3 W R by pi. Now let us try to solve another example, that is a parabolic arch. Parabolic arch subjected to a UDL W per unit So calculate vertical and horizontal reaction. So this is point A, horizontal thrust HA, vertical reaction VA. At point B, vertical reaction VB and horizontal reaction HB. Now calculate the vertical reaction, summation of V equals to 0. So VA minus W into total span length is L and the crown height is H. So VA minus W into L plus VB equals to 0 and summation moment equals to 0. So taking moment about the point A, so VB into L minus W L square by 2 equals to 0. So VB equals W L by 2. So from the equation 1 we can get VA, that is equals WL by 2. Now we are considering a particular section from point A at x distance, x horizontal distance and y vertical distance. The relation between x and y is, for the parabolic arch, y equals 4h by L square into x into L minus x. So you have to apply this formula for the parabolic arch only. Now you have to calculate the moment at this point to calculate the horizontal thrust. So moment equals VA into x, VA equals W by WL by 2 into x minus W x square by 2 . So Wx by 2 into L minus x. This is the bending moment. So we have the formula H equals integration my ds divided by integration y square ds. So H equals integration 0 to L Wx by 2 into L minus x, and y value is here, this y value is this 4h by L square into x into L minus x. 4h by L square into x into L minus x. By 0 to L limitation and y square ds. So 16h square by L to the power 4 into x square into L minus x whole square ds. So if we simplify this formula, this will be like that: W L square 0 to L x square into L minus x whole square ds, and h integration 0 to L x square L minus x whole square ds. So the answer will be W L square by 8h. So W L square by 8h will be the answer, horizontal thrust. Now let us try to solve another parabolic arch. This is the parabolic arch subjected to a point load W at the midpoint at the crown C. So first of all, solve VA and VB. Summation of VA equals to 0, V equals to 0. So VA plus VB minus W equals to 0. Summation of moment equals to 0. Taking moment about point A. So VB multiplied by L, total span is L and his height is h. VB multiplied by L, minus W into L by 2 equals to 0. So VB equals W by 2. From the equation 1, we can get VA is also W by 2. So VA equals W by 2 and VB is also equal to W by 2. Now at any section X, we have to calculate the moment W by 2 into X. So horizontal thrust equals integration 0 to L by 2 multiplied by 2 Wx by 2, and y value is, this is the y, and y value is 4h by L square into x into L minus x dx divided by 0 to L by 2 into 2 y square means 16 h square by L to the power 4 x square into L minus x whole square dx. So if you solve this problem, you will get the value of h equals 25 by 128 WL by h. This is the answer.